Hello friends, this video on Redox reaction part 1 is brought to you by examfear.com. No more fear from exam. The objective of this lesson is to identify the redox reactions as a class of reaction in which oxidation and reduction occur simultaneously. We'll talk about oxidation and reduction. We'll also define the term oxidation, reduction, oxidant, reductant. We'll explain the mechanism for redox reaction in terms of electron transfer process. We'll also use the concept of oxidation number to identify oxidant or reductant in a reaction. We'll classify a redox reaction into combination reaction, decomposition reaction, displacement reaction, and disproportionate reactions. We'll find the comparative orders among various reductant and oxidant who is most powerful, and we'll learn how to balance the chemical reaction using oxidation number and half reaction methods. We'll also learn the concepts of redox reaction in terms of electrode processes. So the first question that comes to our mind is, what is redox reaction? You must have heard of this term oxidation and reduction, and it is scientifically proven that whenever there is an oxidation, there is a reduction. What is oxidation? What is reduction? We'll cover these things in the next few slides. And redox reaction, if I compare with the day-to-day life, is nothing but a person giving, this is person A and this is person B giving money to person A. So in this case, person B is losing money, right? So let's suppose he is giving 1 rupee or 10 rupee. So the person B is losing money and the person A is gaining money, right? So same thing in a chemical reaction. If one element lose electron or one element gain electron, if it is a reaction, the net energy, the net mass is conserved. So if one element is losing electron, the another element has to gain electron, right? Or someone has to gain electron. So we define the terms oxidation and reduction based on the electrons lost or gained. Anyway, we'll go through a history of oxidation and reduction, but this slide is just to show that oxidation and reduction, redox reaction is nothing but where we have both oxidation and reduction. And oxidation and reduction in a real life, if you want to compare that, it is nothing but element A or person A or person B, where person B is giving money to person A. So person B is losing money and person A is gaining money. The next question comes to our mind is, why to study redox reaction? In that, though formally I have not defined the redox reaction completely, but you must have got some idea of reaction where we have both oxidation and reduction called redox reaction. So the question is, why study redox reaction? So if you see, if you talk about the metallurgy, the whole science of metallurgy, where you create or extract elements or metals out of ores, in that redox reaction is involved. If you talk about the purification of metal, there also purification of metals like copper, aluminum, there also the redox reaction plays a critical role. If you see the creation of soap or most of the substance which we use, it happens through redox reaction. You see the working of battery, it works because of the redox reaction, because there's a chemical reaction happens, and that is mostly the redox reaction. You see the process of creating medicines and all, that involves redox reaction. If you see the trees, right, the whole photosynthesis process, this is nothing but a redox reaction. If you see the car, the burning of fuel is also a redox reaction. If you see a lot of stuff around us depicts redox reaction. So having said that, since we have a huge implementation of redox reaction in our day-to-day life, it is good that we understand what is redox reaction. So let's start with the definition of oxidation, the history of the definition of oxidation. As I told, redox reaction is something where you have both oxidation and reduction taking place, right? This is what I told you just now. So what is oxidation? Let's understand first understand the history of oxidation. So scientists in the early area, oxygen is plenty in universe, right? So we have a lot of oxygen, we breathe oxygen. So anything you burn, that means oxygen. So magnesium, for example, the scientists burn and got NGO. Carbon they burn, they got CO2. So they thought they gave the definition of oxidation as nothing but addition of oxygen to element. This is, please note, this is history. This is not the current definition. This is the old definition, maybe in 80s or 1800 to 1700. It's a very old definition. I don't know the actual time. It's a very old definition. Scientists thought, chemists thought that oxidation is nothing but addition of oxygen. That's why you see the oxy word came, right? So if you add oxygen to something, you get oxidation. That time the reduction word was not even coined. And then they observed a lot of other experiments, reactions, because chemistry as a science grew, and chemists got opportunity to understand more and more reactions. For example, if you see CH4, methane reacts with oxygen to get CO2. Also, if you see H2S reacts with oxygen to get sulfur. So with these, they found that oxidation can also be addition of oxygen or removal of hydrogen. Why? Because in this reaction, if you see, from H2S, they have removed hydrogen. This guy has hydrogen is removed, right? This becomes S itself. And this is also oxidation, if you see, right? So they expanded the definition. So earlier they told oxidation is nothing but addition of oxygen. And then they told with more reactions, right? The understanding more reactions. So what they told that oxidation is nothing but addition of oxygen or removal of hydrogen. So this thing was added because they wanted to incorporate this kind of reactions also. So then the popular definition became, for oxidation, you have oxidation means addition of oxygen or removal of hydrogen. Then again, scientists analyze more and more equations. For example, this equation, magnesium, when reacted with fluorine, it gave MgF2. Now they had the doubt whether this is oxidation, reduction. What should we do? The current definition says only addition of oxygen or removal of hydrogen. So according to this definition, we are not able to define this particular reaction, correct? Because in this equation, neither oxygen is involved or not hydrogen is involved. So, but if you see, oxygen is what? Electronegative element. And hydrogen is what? Generally H plus, electropositive element, correct? So oxygen is my electronegative element and hydrogen is electropositive element. So what they did, they have increased the scope. So they told that instead of addition of oxygen itself, they told addition of any electronegative element and removal of removal of hydrogen. Instead of hydrogen, they told any electropositive element. You see, like this. So they have increased the definition, or they have increased the domain of oxidation. They told that instead of addition of oxygen or removal of hydrogen, oxygen is electronegative element. So addition of any electronegative element, hydrogen was electropositive element. They told removal of any electropositive. So the new definition that became popular, in fact we have better definition now for oxidation, is that oxidation is the process of removal of electropositive elements like hydrogen, sodium, sulfur, like that, or addition of electronegative element like oxygen, fluorine, chlorine, correct? Then they have more experiments. For example, sodium reacts with sulfur, give Na2S. Now in this case, if you see, they also observed that in this case sodium was 0 power and this becomes Na2S, that is, this is plus 1 power. So if you see, in this case sodium becomes sodium plus and it lost one electron. So the new definition became oxidation is nothing but loss of electron, correct? So if you see, in this case sodium Na solid becomes Na plus, correct? This is Na plus. I'll make it 2 both sides because this equation has Na2 here. right? 2 Na plus. So if you see in this case, sodium becomes sodium plus by losing one electron. So the new definition became oxidation is nothing but loss of electron, and the reduction is nothing but gain of electron. Reduction is nothing but the opposite of this. So I'm just covering the oxidation now, so I'm just focusing on oxidation part. Correct. So the new definition became oxidation of loss of electron, because they studied a lot of other equations, reactions, and they found that this is more appropriate definition for oxidation. The new definition came after this, that is oxidation is nothing but increase of oxidation number. So we will define what is oxidation number so that your concept will be clear in the next few slides. What is oxidation number, right? And after that, the latest definition says that oxidation is nothing but decrease in electron density. This is the latest definition, but we will stick to more of these two definitions. Right? Either loss of electron or increase of oxidation number. It means all the same, but this is more popular. So increase of oxidation number is something which will stick to. But these were there, this were all historical actually. But yeah, it is good to understand how the definition of oxidation got evolved from addition of oxygen to addition of oxygen and removal of hydrogen, to addition of electronegative element, removal of electropositive element, to loss of electrons, to increase of oxidation number, to decrease in electron density. So the definition evolved. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.